Hello guys, welcome back to my YouTube channel. My name is Kuda Kwasham Shaike. I'm a software engineer who's been interviewing for the last couple months for engineering roles, and I'm here to talk to you today about a system that I've been advocating for solving LeetCode problems. So traditionally, the system that a lot of people suggest in different books that you probably have read, including cracking the coding interview, is some sort of like finding a brute force solution to a problem and then working through to optimizing it to making it better. I'm kind of putting a spin on that and focusing more on the patterns of finding patterns in the problems that you see. One thing that I've realized, and most of you probably have at this point if you've been doing a lot of LeetCode problems, is that they can be subdivided into really maybe 6 to 10 different topics, right? Or different strategies or different algorithms. And if you learn those algorithms and purely really learn them, and you really understand them and you enjoy them and you make them part of your life, it becomes very easy for you to finish and to actually be able to complete and to do well in your interviews. I don't think it's just about solving the problem in an interview, because if it was just about solving the problem in an interview, a lot of us would have jobs. But right now, especially in this market, they're expecting you to be perfect. They're gonna be nitpicking you, so you need to come on strong. And one of the tools and ways to come on strong is to have seen the question prior. Sometimes you may not have seen the question prior, the actual question, but if you've seen the pattern in the question, I'm going to teach you how to be able to apply the pattern and about to be able to remember the pattern and be able to apply it to different problems that you see. So in the previous video of LeetCode strategy, I saw a lot of you watch that video, and I saw that there's a deep need to really learn how to prepare for LeetCode style questions, and that's what I'm going to do in this video. But specifically in this video, I'm actually going to be sharing my screen, walking you through how to build understanding of interview patterns. Today we're going to focus specifically on two-pointer. The reason why I'm focusing on two-pointer is that it's at the apex, it's at the tip, it's where we start. So normally you would start with arrays, right? So let me start sharing my screen here. Let me see. I'm gonna start sharing my screen here so you guys can see. I think I've started sharing my screen. Hopefully you guys can see my screen. So you see how the structure here, guys, is like it starts with this roadmap. I'm using LeetCode's roadmap. And as you can see here, he starts with arrays, right? And then you go to two-pointers, stack, binary search, sliding window. So we're gonna focus on two-pointers because it's one of the earlier topics you get to do that doesn't have too many prerequisites, right, that you have to look at. So that's what we're gonna do today. For that, I want to backtrack a little bit and show you how to sort of separate. So for a lot of my mentees, I've been telling them the strategy of interviewing, where it's like when you get to the interview, you don't want to be figuring out what to do. You don't want to be figuring out what to do. All you want to be figuring out is you want to walk into the interview with an abstraction. So you want to walk out with the algorithm half figured out already, right? So when you walk in an interview, you're not trying to figure out the entire question. All you're trying to figure out is the layer on top of the abstraction, right? You're trying to figure out what I call the flesh of the question. So in any question that you're gonna find, if it's under two-pointers or under DFS or BFS, it's gonna have the same exact skeleton, and then it's gonna have a little bit of a twist, and that's what I call the flesh. So I'm gonna show you how to figure out the fluff and how to figure out the skeleton, or how to walk in with skeleton, what exactly the skeleton is in specific to two-pointers today, and then we can navigate other areas later. So let's start with two-pointers. These are the questions that are on LeetCode.io. I think some of you are probably familiar with LeetCode.io. He's the guy behind this. And so I'm going to be doing those problems, some of the problems that he has here, to illustrate the strategy that I'm talking about. But before we do that, let's do one thing really quickly here that I think will be super helpful for you guys. Let me do something real quickly that I think will be super helpful. Let's go to the interview patterns, right? I want to show you something. We're just gonna do a little bit of a history lesson here on like why 2 pointers, like why do 2 pointers matter, and why these systems exist in the first place. So the first thing that I want you to appreciate is that 2 pointers are used most often to sort of like optimize solutions. I guess that's why traditionally some experts say, oh, find the most optimal, find the least optimal solution first, brute force it, and then optimize it. I don't agree with them completely, and the reason why I don't agree with them completely is sometimes once you found the brute force solution, it's hard to optimize it. Sometimes it's almost impossible to optimize it. There's certain situations where the brute force solution is actually harder to find than the optimal solution. And I actually did a question right now today with some of my mentees on a solution that it's much easier if you do it in the most optimized approach right off the bat. And I think some of you can think of problems like that. So that's why I recommend a pattern first approach rather than an approach where you're learning to problem solve and brute force and then come back to optimizing it. I think there's more bang for your buck. The other reason why I don't recommend brute force first is that most of these companies in the industry that we're in at the time that we're in, they're not going to take your brute force solution. I've had interviews where I did a brute force approach. I had an exact interview at Roblox where my brute force solution worked precisely, worked so well, and I even talked about improvements that I would make. But the fact that I didn't have the try solution that they wanted me to build a try but I used like other methods that were essentially had the same time complexity, but he just wanted to see a try because I think that in their notes somewhere they said like the person should build a try. So I'm saying this to say like sometimes it will save you a lot more time to just go directly to the most optimized solution. And the most optimized solutions, most of the time, they're under these patterns that I'm going to teach you, because normally the reason why these patterns exist or these algorithms exist in the first place is to optimize solutions to problem sets. But the second thing is like people are not getting hired for brute force solutions. There are thousands of people applying for the same job. So trust me, there's someone who studied more than you who's going to do the try solution in a place where you did the normal string array method. So okay, so let's talk about 2-pointer. So 2-pointer is a pattern, is a versatile technique used in problem solving to efficiently traverse or manipulate sequential data structures, right? And keyword sequential data structure. So this is a kind of pattern where you want to see if ever you have a sequential data structures such as arrays or linked lists, and then you're being asked to find 2 elements in the list that add up to a target, or you're sort of like you need 2 pointers to be able to solve your problem, or you're navigating an array from 2 different directions. The first thing you probably should think about is 2 pointers and see how you can apply the concept of 2 pointers to your problem, right? So let's look here. Let's just read the history here. So whenever there's a requirement, this is exactly what I was just saying. Whenever there's a requirement to find 2 data elements in an array that satisfy a certain condition, the 2 pointers pattern should be the first strategy that comes to mind. I like that they say the 2 pointers pattern should be the first strategy that come to mind. So think of these as strategies. Think of these patterns that I've been telling you guys as strategies. Think of it as like tools in your toolbox, right? Like it's your armor, and you should make sure that it's part of your artillery. Like anytime you're in war and in your LeetCode war and you want that job, and you see it, and you see an array, and you see that there's a requirement to find 2 data elements in an array. Think 2 pointers, right? And these pointers normally they adjust their positions dynamically depending on the conditions or criteria in the question that you're doing. Okay, so the pointers can be used to iterate through the data structure in one or both directions depending on the problem statement. For example, to identify whether a string is a palindrome, we can use one pointer to iterate the string from the beginning and the other to iterate from the end. At each step, we compare the values of the 2 pointers and see if they meet the palindromic properties. That's funny because that's the first question we're gonna do. And I wanna show you, in the first question, all I'm gonna do is I'm gonna introduce the idea of 2 pointers. And in the second question, I want to show you how the second question is essentially the same as the first question. And then I'm going to do that for the third question as well. So by the third question, my hope in this video is that you can appreciate that all these questions, literally all these questions, they have the exact same code. You can literally copy the same code. They have the exact same structure, the exact same code, but the elements to it that are just fundamentally different. And if you hear anything in this video, I want you to remember that any new problem you're seeing, it's actually an old problem with new flesh. So your preparation for LeetCode questions should all be about understanding the skeleton. Understand the skeleton so that next time you see it, you will know to abstract that skeleton and just fill in the flesh. I hope that makes sense. If it doesn't, I hope by the end of this video it does, because that's my entire goal. It's just to help you appreciate the idea of the abstraction of how you remove the skeleton from each problem set that you see. And then specifically, we're gonna look at 2 pointers here. So 2 pointers are powerful as well because they make an algorithm that could have taken order n squared time complexity to take order n. So if, for example, the palindrome function we're about to work on, you can do it in order n squared brute force approach or the naive approach. But with 2 pointers, it comes down to order n, right? And if you, for example, if you're looking at an array of sorted values, that's another question we'll do, and you had a target and you're looking for 2 values that add up to the target and it was a sorted array, the brute force approach of doing that would be to have 2 for loops where you're finding those 2 values of I and j in your array. But you can just use 2 pointers because it's sorted and it's sequential and it's an array. Again, think 2 pointers every time you see that. Okay, so let's get started. Let's get coding. And now that I've told you the history, I don't want to waste no time. Let's get to the code. Okay, so let's read the question first. So I'd written some quick notes here, but let's read the question first, right? Given a string s, return true if it is a palindrome, right? Otherwise, return false. A palindrome is a string that reads the same forward and backwards. It is also case sensitive and ignores all non-alphanumeric characters. After considering, so we have an example here. It looks like they are transforming it first to something that meets the conditions, and then of course, like you know, we're using 2 pointers here, so we would compare. We would probably need to make this into some kind of array, because again, remember guys, we are trying to transform the problem to fit into the idea of 2 pointers, right? And the first thing that we were told again is that you want your data structure to be an array or a linked list. So in this case, I think the most efficient thing to do would to make it an array. Right now it's a string, so we'll convert that into an array. But before we do that, we want to make sure that it's cleaned up, right? We want to make sure there's no cases in it. And so we want to make sure that it's case insensitive and that it doesn't have any non-alphanumeric characters. Okay, that sounds good. Let's do that. Let's go ahead and do that. And then as we do that, I'm going to be explaining how this fits into 2 pointer and how to look up for 2 pointer problems. And I'm going to build the skeleton with you guys. So the skeleton that I'm going to talk about today is that, as the name suggests, you have 2 pointers. That's the first one. Your pointers should move somehow, right? Right. So that's the skeleton that you're always gonna have. So in any question, when you realize it's 2 pointers, the first thing you're gonna do is write the 2 pointers. Literally. And then you're gonna have some while loop, right? Some while loop to do your movement, right? And then you're gonna have some kind of like conditional, right? Conditional to either break or return. So that's the skeleton. This right here is that this is gonna be true in any question you see that's 2 pointer. So okay, let's get started. So we're gonna do exactly what we just said up here. But before we do that, let's appreciate the flesh. What's the flesh here? The flesh in this case is a few ones. We have to clean up the string. It's a string input. check that the elements at the 2-pointer are the same. That's the flesh. That's the only difference between this and another question, right? The difference between this and another question is like, instead of adding the elements at our 2 pointers, here we're comparing those elements. We're trying to make sure that they're the same, or they're, and if they're different, then we return false. Here we're just returning a Boolean. Okay, so let me write that down too. So in any question you get, figure out the skeleton, which is the 2 pointers. It says it on its own, right? You figure out the 2 pointers, you know your 2 pointers are not supposed to move. You know you have a while loop and you have a break statement in there, like some kind of statement that are conditional, right? And then your flesh is literally this. We need to clean up the string. It's a string input, and then we need to check that the elements are different. Okay, so let's go. Let's clean up the element. Let's clean up the string first, right? So that it matches whatever it is that we want it to be, right? Before we do any sort of computation to it. I think here I'm gonna use a regular expression to sort of clean it up. I'm gonna use a regular expression that makes sure to ignore or to remove or replace any sort of instances. It's gonna match anything that's not a character, that's not a to Z lowercase or A to Z uppercase or a number, right? And then once it matches that, I'm gonna use the replace function, replace all function. Okay, so let's write our regular expression. So our regular expression is gonna be something like this, right? So let's say let regex is equals to, I think it's gonna be something kind of like this, where we have like, so I guess we want anything from 0 to 9, anything from A to Z, and then anything from A to Z. These are the things that we want to, these are the things that we want to include. So we wanted to match anything that's not this and remove it, right? So, and we want to do that across the string. So that's, for those that don't understand regex, what I'm doing here, this says, says like not to include, so not to include, and everything that's in this box means like, these are the things that I want. So I want something that's not all these things, right? So you'll see it in a bit. So this is my regex, and then I can say s.replace, or I want to replace all instances where I see this, anything that matches this regex. So what this replace all method does is that, like it says, a string containing the text to replace for every successful match of successes in the string, replace all instance of a substring in a string using a regular expression or string, and you pass it in a regular expression, and then you pass in the replace value. In this case, we want to replace it with an empty. So this is my regex. So let's call, so this is gonna be the new string. So clean string is goes to s.replace the regex. We're gonna replace, let's just console.log it, clean string, just to make sure that it's making sense. Okay. Okay, so it hasn't replace all regex, A to Z global. Oh, okay, I was supposed to put this in here. Sorry guys. Okay, yeah, there it is. And then we want to change this to lowercase, so that we'll clean up the string. All right, so now it looks exactly like this. Now we can start our comparison. Because it's a string, we want it to be an array. So let's say string array here is equals to clean string dot split, and we can split it in just an empty, and then this will create the string array that we want. I like to test my things as I go so that I know that the assumptions I'm making are correct. So you see how now it's exactly how we want it. Okay, so now that we have done that, so let's continue going. I think since this is not changing, this can just be a const, to be honest. Okay, so now let's do this. So now we've done the flesh, right? We've done some of the flesh. So we've cleaned up the string. So this is done. And it's a string input. Okay, so we've considered that. That's done. Check that the elements at the 2 pointers are the same. Return a boolean depending. Clean the string regex. Okay, let me just clean this up. Okay, so we've done these two parts. This is what's left. Now let's do the skeleton, right? This is the skeleton that's going to exist in everything that we do, right? The 2 pointers. Maybe let me move it. Let me move it here so that you guys have a full appreciation of how this works. So let's start with, okay, skeleton, 2 pointers. Okay, so let's say let left is equals to 0, let right. You're gonna essentially write the exact same thing, and you're gonna see that the same exists for other patterns that sort of lean on 2 pointers as well, and that's the what you call it, the sliding window pattern and the binary search. It's exactly the same thing. You'll notice that it's exactly, you could really write it while you're sleeping. At this point, I can write this code while sleeping because I know I can't make a mistake, right? Because you see what I'm doing here? I'm not even thinking at this point because I know that because the skeleton is the same. So here I just wrote this. This is really what I just wrote. And you could even start the interview. You don't have to think about this part. You know that you already need 2 pointers, and you know that the left needs to be less than the right. I'm not thinking about this. I'm not thinking about this, right? I'm not even thinking about this. So this is the while loop to do a simple conditional to either break out of the loop or something. Like now that I've written the loop, now I'm just writing the flesh. So now I'm filling in the flesh. Okay, so let's fill in the flesh. What's the flesh say? The flesh say, well, check that the elements and the 2 pointers are the same, right? Okay, so let's do that. So let's say string array, if string array at left is not equal to string array, at right, then here we return false here because it's not a palindrome. Otherwise, we just keep going, right? Otherwise we return false. You return true here because that means, okay, we're finished and there's nothing that's against us. Okay, all right, now let's just clean this up. So you see, guys, okay, now let's run that since we're basically done. There we go. Let's submit that. There we go. See that, guys? That's it. Literally, that's it. So, again, I want you guys to appreciate that this was a given. All that was different was this. In a different question, in the next question, we're going to do another question, and you're going to see exactly what I'm saying, that these questions are exactly the same thing. So you don't need to memorize. That's what I was saying in my previous video, that you don't need to memorize the question itself. Like, there's nothing here you would need to memorize here, right? Because any question you're gonna get, even you may not get the same exact question. You know, it may be asked different next time. But if you have the appreciation of like seeing, oh, it's a 2 pointer, then you can just have the skeleton ready to go, and all you need to do is figure out the flesh. Okay, so we're gonna do that again in the next question, so that you guys can have an appreciation. Let me just clean this up. Okay. Cool. Let me clean this up. You guys made my code ugly because I was trying to explain things here. Okay, so let's go to the next question. The next question, I haven't done it. Okay, let's do this question now. Sorry, someone was trying to call me. So to sum, you have numbers and you have a target. Okay, cool. Let's read the question. Make sure we understand it. So the question says, given an array of integers numbers that is sorted in non-decreasing order, return the indices, one indexed, of 2 numbers, index 1 and index 2, such that they add up to a given target number, and index 1 is less than index 2, not that index 1 and index 2 cannot be equal, therefore may not use the same, therefore you may not use the same element twice. There will always be exactly one valid solution. Your solution must be order 1 additional space. Okay. Okay, so that means we can use a map here, right, guys? We can use it because this is a two-sum and we can't use a map. Okay, so let's do this. This is fun. The sum of 1, 2, 3. Okay, so this is an example. Okay, okay, that's cool. That's cool. Target is 3. Output is 1 and 2. I think the output is at the indexes. Okay, so let's write down the key elements, right? So let's write down the skeleton. Let's write down the flesh. The skeleton is, again, 2 pointers. All right, let me tab this. 2 pointers. Move them, and then break when you have a valid solution. Move the pointers. That is sorted in non-decreasing order. Okay. So move the pointers left and right as needed. Okay, so this is the skeleton. It's gonna be the same. The flesh now. The only thing that's different from this question to the other one is like now we're doing a sum. We're doing a sum of the values at the indexes and checking if they equal the target. That's it. That's the only difference. That's the flesh here, and that this is sorted. It's sorted. So that helps us. So like, look out for the keywords. So this is sorted going up, right? Okay. All right. So let's just go ahead and write our skeleton. Okay. So let's start with our skeleton here. Let's say left. This goes to 0. Right. Exactly what I had initially, guys. I could even go back and copy it. I think I should do that so that you guys see how this is the same exact stuff. Okay. That's what I'm going to do here. Look at this. It's going to be fun. Look at that. We're going to use the same, my formatting here is off, guys. I should probably just tab it. I think some people are going to be mad at me because some people don't like tabs. I don't mind. For me, I just want to get the job done. Okay. Okay, so instead, okay, we're trying to get a target, right? So remember I said this is the flesh last time. So the flesh changes. So I deleted that because we're not going to need it like that. And yeah, so to sum, the function, so this is supposed to be tab. Okay, so okay, cool, guys. So you see what I'm doing here. I need to tab this, guys, as well. Okay, so all right, so we're trying to add the target. So okay, let's check if let sum is equals to numbers at right, at left, plus numbers at right. If sum, and we just say if sum is equals to target, then we want to return sum is equal to return left, right. That's it. If sum is equal to target, return left, right. And then you just keep doing that. Then you just keep lefting the left and then righting the right. But sometimes what may happen is that I think we have other corner cases as part of the flesh, right? Because let's say this plus this is not equal to target. then that means that you see how when we added these two numbers, they're greater than target. Then that means we need to move left. We need to move in on the right, right? We need to move, if that makes sense, like we need, like, cause it's sorted, then that means that, then that means that, we want to add, we want to make left, we want to move the right one in, right, and add these two values instead. Okay, so let's delete this as well, because we're not just moving all the time. Okay, so if sum is equal to target, then we return left and right. And then if sum is greater than target, if sum is greater than target, then that means we want to move the right in. Right, that's all we want to do. Else we want to, else, I think we can just say else, we want to move left in. And then, yeah, that's it. That's it, guys. That's it. Otherwise, if else, otherwise we want to just continue. Okay, so one, let's say 1 compared to 4, right? 1 plus 4, and that gave us 5, right? 5 is greater than 3, so we move the left, we move the right to the left, right? And then we say 1 plus 3 is 4, so we're like, okay, no, it's greater, so we move right to 2, and then we add them. Okay, so yeah, that's it, guys. That's it. Let's run that. Okay, it's because I took some skeleton stuff from the outside. This was supposed to be numbers. No one corrected me. Damn, guys. That sucks. Okay, so we have the wrong answer. Your output is 0, 1. We expected 1, 2. Okay, let's see where we're going wrong here. So while left, let numbers, we're starting at left and then numbers dot length minus 1, while left is less than right. If sum, let sum is close to numbers of left and numbers of right. If sum is close to target, then return left and right. If sum is greater than, yeah. Oh, no, they messed this up. One index. Okay. You see, guys, this is why you have to read instructions. One indexed. So, okay, that's fine. So what we can do is we could just return left plus 1, right plus 1. I guess. Yeah, I guess. Okay, cool. Guys, read instructions. Don't be like me. Okay, so again, you see the only difference that we had to change here is that we were not moving the left and the right sequentially, right? We're not moving left and right all at the same time. We kind of had to be aware of like when we're moving the left and the right, and that's this flesh part. We're going to some of the values and then checking if they're equal to target, right? And move is needed, right? Move the pointers left and right is needed. But we knew like all this code, we could just copy paste it from somewhere else. And all we had to do is figure out the flesh in this case, what makes this question different. So the first thing we should always think about is like, okay, what's the skeleton and what makes this question different? We know we need 2 pointers. We know I'm going to write 2 pointers at some point, but what makes this specific question different? is the appreciation that you need. Okay, sounds good. Let's move on to the other question. Hopefully, if you haven't understood it yet, hopefully this question will kind of bring it home. All right, we're probably gonna need some of this stuff in the next question. Okay,